Hello and welcome to a new episode of Build on AWS UAE. Today we have 30 minutes that we're going to spend together, and we are going to discuss how we can serve your web applications in a way that is faster, cheaper, and more secure. So what kind of web application we're talking about, right? So there are websites, pages that we load on our browsers to do different things, such as, buying stuff, booking flights, booking our holidays. For example, I recently became a father and I go almost every day, not every day, but very often to order stuff for my baby on Mom's Word. Then you have those mobile applications and APIs that you can use for different kind of things, such as ordering food using Talabat or Kareem. And of course, we have the video streaming use case, right? When it's Ramadan and we're watching our favorite series on Shahid, or we're watching some live football matches or cricket events on Stars Play. And of course, there are the software downloads, patches, and so on, and games if you are in the big gamers. Personally, I'm not. All right. So the thing is, to access those applications online, we need to go to the internet, on the internet. And that's the challenge that we are going to talk about today. The challenge with the internet, it is an unpredictable place. Before your request go from your browser or your mobile to where the application is hosted, such as in the UAE region, Bahrain region, or in the future region in Saudi Arabia, it has to go through different networks, different hubs. And on that path, a lot of bad things that can happen, right? So we can have like network failures, congestions, BGP leaks, and things like that, right? Which impacts the performance and the availability of the application. And then the internet is home to different kind of malicious activities, such as bot traffic, DDoS attacks, and malicious traffic that are trying to take advantage of vulnerabilities in your application, right? And so, okay, what can we do? This is where the Edge story, the AWS Edge story comes into place, and I would like to talk about it today. I have a few slides to explain the concept high level, then I'm gonna demo it through a fictitious retail application that I created for you. So let's get started. A quick intro about myself. My name is Ashraf Souk. I'm a principal solutions architect focused on the edge services of AWS. So mainly it's CloudFront, it's AWS WAF, Lambda Edge, CloudFront Functions, and AWS Shield. I've been here since 7 years. I'm one of the oldest folks in the Edge team. I like to create a lot of content, whether it's blogs, white papers, and videos like this one. I'm owning the Edge Services section of the AWS Developer Center. Share the link at the end. And I contributed to some popular projects like the image optimization one or the recent CloudFront hosting toolkit. If you're interested in this domain, follow me on LinkedIn. I post a lot of content that could be interesting for you. All right, so what is the Edge network? Okay, I talked about it. So you already know about the regions, the tens of regions that AWS has deployed worldwide, such as the two ones that are in the Middle East and the third one that is coming, announced and coming. But that's not the full story. AWS also has deployed hundreds and hundreds of edge locations, okay, across tens of countries and hundreds of cities. And the idea here is that in these locations, we are deploying servers and network devices to make it as the entry point for online application to your regions, right? So instead of users going through the internet, different hubs to your applications, first they are going through the entry door, Edge services, and from there to your application, okay? So why is this important? First, with this very distributed network, edge locations are within 10 milliseconds of any major population center in the world, okay? It is sitting on a global network that is managed by AWS, owned and managed by AWS, based on 400 gigabit redundant links, which makes the application less impacted by any issues that are happening on the internet. And with this scale, we are able to, at one side, to absorb large attack traffic, DDoS attack traffic, but also it gives us intelligence with the different things that we're seeing on our network. For example, every minute we analyze exabytes of logs, and we see on a daily basis hundreds of millions of possible malicious interactions, as well as thousands of DDoS attacks that are mitigated automatically. So in the region here, we have multiple locations in the UAE. We have two main edge locations in Dubai, in Fujairah, but we have also in Oman, in Bahrain. We recently deployed multiple ones in Istanbul in Turkey, also in Egypt, which basically dropped the latency in this country by 30% for applications that are using AWS Edge services. And we have a couple of others that are coming by the end of the year. Stay tuned to learn more about it. All right. So how does it change the performance and the security and the availability of your application? So what happens is the requests that are coming from users are ingested or are they enter the AWS network from the nearest location within tens of milliseconds, right? For example, through the CloudFront edge location. And CloudFront is AWS's content delivery network. I'm going to explain more later on what it does. So from the edge location to the AWS region or the cloud, or even if it's on-prem, there is a highway. Let's say it's a highway where the traffic is backhauled in a way that is much faster and much more reliable. And what is important is that the kind of attacks that I described earlier are blocked at the edge level. So you do not need to wait until they reach your origin or your application to block them there, because sometimes it's too late. You have to scale and so on to absorb it, right? So you do it very far from actually your application. All right, so let's talk a little bit about the fictitious application that I developed. I called it the Recycle Bin Boutique. So it's a store, online store to sell environment-friendly articles. Okay, and for the reference, I used Anthropic's Sonnet to help me code it, because I'm not a big expert in Next.js technologies, so I use it to help me do the design, generate the images, even generate the list of products and the description. It kind of helped me a lot to gain time and focus more on the configuration of CloudFront, WAF, and so on. All right, so what's the architecture? So as I mentioned, it is based on the Next.js framework, server-side rendered. It is hosted on EC2 instances behind a load balancer, application load balancer, and the backend where I store the product and the user table is in DynamoDB. And also I implemented a image transformation solution that we don't see here in the picture, but the diagram, but basically the images are transformed and placed in this S3 bucket. I use the Bahrain region here, and so first thing is I put CloudFront as an entry point for this application, and using CloudFront I can do different things. So first I can enable caching, to cache things that can be cached, like images, JavaScript, and so on. And for the dynamic traffic, so the traffic that needs to go back to the EC2 instance, they are still going through CloudFront, but just as a reverse proxy with caching disabled, right? And on CloudFront as well, I have used what we call edge function. So it's a bit of code that is running at the edge with a key value store. So it's like a state that is maintained globally on the network. that you can use to deploy stateful functionalities. And here it is to showcase things like A/B testing or redirections. And the idea is, okay, we can do them as close to the user instead of waiting for the request to go to the origin and do the redirection and so on. And from security perspective, CloudFront integrates with AWS WAF, which is the web application firewall, with capabilities such as bot control, to identify and manage traffic that is coming from automated agents. All right, and I deployed all of that using CDK, infrastructure as a code, so it is repeatable, and I'm planning to publish this in the future when it's like polished and ready to be published. All right, so now it's demo time. Let me show you a little bit those different concepts on this store, okay? So the first thing is that I would like to show you actually is the protocol that is used to serve the page. So it is HTTP3. Although the load balancer does not support HTTP2, I'm able to send the traffic on a more modern protocol that makes the website faster, because in comparison to HTTP2, it's much easier to do one round trip delay to actually establish a TLS and TCP connection. Actually, it's not a TCP connection, it's a QUIP, but the equivalent, right? So that's the first thing. It's like out of the box. You need to enable it in the CloudFront distribution. Then the other thing that I would like to share with you is for the dynamic acceleration. So this is the page, the first request that came to the page, to the home page. And if you look at one first header, it's a miss from CloudFront. So it means it went back to the load balancer, right? But if you look at another header, which is called the server timing header, it shows you where the latency was spent on its path going to the origin. And you can see that actually the duration for DNS upstream and the connection upstream is 0, which means that CloudFront used a connection that is already established, TCP connection already established from the edge location to the origin to send the traffic. It didn't have to go through establishing a new session at all. Yeah. So this is a gain in performance for dynamic traffic, and this is something that is not very known about AWS CloudFront, and like in general using CDN for dynamic traffic. I'm trying to evangelize it as much as I can. Okay. So the other thing is like is caching. This is like much more a popular use case. In this page, I cached JavaScript. I cached the images. So we can see if we can go and see like, hey, this is a cache hit from CloudFront, and every time that there's a cache hit, basically the content has been served directly to me from the UAE instead of going back to Bahrain region, and also it means that I'm reducing the cost of scaling my application in Bahrain, right? So this makes my application cheaper to operate. Another thing that I did is the image optimization that I mentioned to you. Okay, so if you look at the content type of this image, it is WebP, right? So what this image optimization solution does is actually using a CloudFront function. It detects the capability of the browser. This is a Chrome browser. It knows that it can accept WebP format, so it transforms. It sends the signals upstream using a Lambda function to transform the image from JPEG to WebP, which makes the image quite smaller. So again, faster to serve, faster performance, but also less data transfer out for you to pay, right? So this is one kind of compression. And by the way, this solution also does image resizing that is decided by the Next.js framework based on the port viewport. So here, like, it is asking for 2000 by 2000 image size. All right, so let me show you something else. So I talked about the Edge functions. Okay, so here I would like to show you two use cases that I implemented with Edge functions. I'm gonna go to some page that does not exist, and basically I get this page does not exist. Sorry, it means that the request went back to the origin. Okay, so using a CloudFront function coupled with key value store to store the different redirections that I would like to implement. Actually, I can do the redirection right on the edge, and nothing needs to go back to the origin. And to show you this, how it works, I will go to the key value store that I'm using. And actually, I have included in it like two rules, okay, that are being executed in the function. The first one is, if you see like a request coming to old campaign, redirect it to the home page. Okay, so I will actually do that. Oopsie. And then, okay, we were redirected to the home page, right? We didn't get the 404 error code. Okay, so those were like a couple of capabilities that accelerate the website. Now let's talk about the security bit. Okay, so back to the tab. Basically, I have a web ACL that is associated, so I'm gonna show you what's in it. I created different rules for it. So there are rules that blocks based on IP reputation lists that are known for doing DDoS attacks or like conducting malicious scanning activities and so on. I added like a rate limit that has the 400 threshold that we're going to test. But you can add different kind of rate limits, combine it with countries, other dimensions. And I added a couple of managed rules from AWS WAF. One is a general protection against automated bot traffic, and two others more focused on protecting login pages from credential stuffing attacks or like account takeover attacks also. And the other one is for account creation fraud, right? To detect that and block that. I'm gonna show you a little bit, a couple of examples. Okay, so just for you to know how the bot control works. Basically, there is a script SDK, JavaScript SDK that is embedded in the page. And when the page loads, it actually go and do a challenge. Like it tells the browser to execute a JavaScript challenge. This is it basically. So this is like, to download the challenge, and then afterwards to actually execute it and send back the result. And based on that, WAF will be giving a cookie, creating a cookie, right? This is the value of the cookie. And it's assigned data that identifies the session and also notes the different characteristic that we have seen from the client, right? If there was some indication that this was an automated bot and so on. Okay. So let me show you first using first like the IP reputation. Okay. So I opened a couple of pages for basically a VPN service. Sometimes the VPN service uses IP that are not identified. So I opened multiple ones to show you. And what I did is to configure a CAPTCHA response when a VPN is detected. Okay, so there is something that is going wrong here. Oh, something went wrong. Okay, let me try again. All right. So I'm trying again. All right. So I got the response. I got the CAPTCHA actually. So now I have to solve the CAPTCHA, right, in order to be able to go through this website. So this is like one example of of like a protection, like using a captcha that I configured for requests that are coming from VPNs, okay, or malicious IPs. Okay, another one. So another one is, something, I am going to use a Selenium headless browser, and I am going to scrape the page. Okay, so I'm gonna run this for you. This is like a script that I've written. So first it tries to load the home page, and then it tries to scrape the product link, but it didn't work because if you see, it got detected right away. All right, so that's another example. Another thing that I wanted to show you is rate limiting. Okay, so this is another. Actually, let me clear the screen. This is another test that I will be doing. Actually, it's better to do it from not from the script, but from Cloud Shell. Let me go to Cloud Shell and do it. So I'm going to send first 400 requests to the application, right? And then I'm expecting that after that the request will be blocked because I would basically go beyond the threshold that I configured the rate limiting rule. So let's do it. So you see here right away we started to get 202. So this is a JavaScript challenge, right? To say, okay, you sent some amount of traffic, right? So I want to challenge you. But then after that, after passing the 400 request threshold, now we're sending more requests, and we'll see in how much time the rate limit will block. Okay, so we're expecting a 403 response. Okay, so we got it after 16 seconds. The IP was blocked. All right, the last one that I would like to show you is basically how to protect against credential stuffing. So attacks, right? So there are so many different layer techniques that needs to be used, right? For example, client-side detections of automated browsers and stuff like that, different kind of rate limits, but also behavioral detections, such as what we call like password traversal attacks, which is, hey, I'm gonna use, like, I have a username, I'm gonna try so many different passwords until one of them is successful, so I can go and basically do fraudulent activities on the account of this user. So first I'm gonna show you like a normal login. All right, now I'm logged in, right, as Ashraf. I'm gonna log out again, and now I am going to basically try different passwords and see how it goes. Okay, so here I'm receiving a 401 invalid credentials. Okay, this is normal. It's the backend that is responding. It's saying this is invalid credentials. But then after some time of trying to sign in, an error is occurred. If you look at the screen, we received like a 403, which was blocked by WAF. So this is what I wanted to show you with the limited amount of time that we have today. I would like to end this talk with a couple of stuff. So first, I mentioned in the beginning the Edge Edge services section in the AWS Developer Center. It's called Application Security and Performance. Here's the link. Please go and have a look. We have a lot of like bite-sized, I would say, articles focused on the most common topics that customers come to us and ask us about. Like how can we do A/B testing, image optimization? How can we implement bots? How we do geo-blocking or DDoS protection and so on. So you can find a lot of useful information, and it is being kept up to date. Other thing is, as I mentioned, like in a continuous manner, I blog and share insights, information updates from the Edge domain in AWS, but also from our industry. So feel free to follow me on LinkedIn if this is an interesting, something interesting for you. And if you have if you're operating a web application and you would like to explore how you can make it faster, and you would like to make it more secure and cheaper overall to operate, so reducing your AWS bill, please get in touch with us. We'll be happy to help. Thank you very much, and bye-bye.